Hello, my amazing students. This is Mrs. A, and I am back with 1.3, and we're going to be doing about every 10th problem again as we go through the problem set, just to try to hit everything that you might need. Some of you are taking this test tomorrow, so I hope you've already learned this somewhere else, but I'm trying to get it posted with my very slow internet. So here we go with 1.3, and I'm going to turn around so that you're looking kind of over my shoulder at the screen, because then you can see me right as I do it. So that's what I'm going to do. Okay, so the first problem that we are going to do is to find the slope between these 2 points. So we know that the slope formula is m is equal to y2 take away y1 divided by x2 take away x1. So that's your slope formula. And it does not matter which point we choose for x1 or y1, which point we say is first point or second point is what I'm trying to say. And as long as we are consistent. So let's just go from this direction to this direction, just for the sake of it. So we've got 6, take away a -9 in my y's, and then subtracting the same direction, I'll say 4, take away 4. Oops, what happened? I've got 4 take away 4, which is a 0 in the denominator. So the slope of this line is undefined because I have a 0 in the denominator. Now, do not on the test leave 15 over 0. If you leave 15 over 0 as the slope, you will not get full credit for that, because you never went that extra step and said that means it is undefined. So you want to make sure you go all the way with that one. Okay, so the next problem we're going to do here is number 21 in 1.3. And again, we have 2 points. So we're going to subtract the y's. M is y2 minus y1, -5. Take away a -13 over -8, take away 16. Okay, so when I perform that operation, I've got -5 plus 13 is going to be 8, and -8 minus 16 is -24. Okay, so I still need to do something else to this. I need to simplify. So -1/3 is the final answer, and my slope is -1/3. So that was number 21 in the homework set. And then this is number 30. And we have 2 points, but they're written a little bit differently, aren't they? Because we have g of -9/2 is 2/9. That means that this is the x value, and remember the g is equal to the y value. So this is the y value. So this is the x value, and this is the y value. So the point is -9/2 2/9. And this point over here is going to be, this is the x and this is the y, so it's going to be 2/5 and -5/2. Okay, so now we have some fractions to deal with. We're going to find the slope the exact same way, but we have to deal with some fractions. So now we're going to say -5/2 take away 2/9 divided by 2/5 take away a -9/2. Okay, so now when I subtract, notice I have all of these different fractions. Now there's one thing that you can do when you have, this is called a complex fraction, right? Because it's got fractions within a fraction. And one of the ways that you can deal with that very effectively is to multiply both the top and the bottom by the least common multiple of all of the fractions. So I've got a 2, and I've got a 9, and I've got a 5. And the smallest number that all three of those will go into is a 90. So I'm just going to multiply by 90 over 1 and 90 over 1. Okay, now one cool thing about this is you can do this without doing much math at all. Okay, so I'm going to end up needing 2 boards for this because I started over too far. But a negative times a positive is a negative, right? And 90 divided by 2 is 45. So I'm going to end up with negative 45 times 5. So negative 45 times 5. Notice I'm not even bothering to do the math right now. Okay, put a little parenthesis, and then we'll go get a new board to spread it out. And then the 9 and the 90 are going to cancel, and I'll get a 10 times a negative 2 is a negative 20. So I'll put my negative 20 right there. Okay, that's my numerator. Notice no more fractions in the numerator, just a bunch of numbers I got to do math with. So now 90 divided by 5 is 18 times 2 is 36. And then I'm going to have plus, because I got a minus. And then 90 divided by 2 is 45 times 9. 45 times 9. Okay, so that's what I've got right now. I've got a lot of math to do. I've got to multiply 45 times 5, take the opposite of that, add it to negative 20. That's a lot of math. But the cool thing is that usually there's a trick if you're persistent. And I'm going to show you the trick. Just a moment. Okay, so now I have rewritten our expression that we have to simplify. We're still on problem 30, but notice I don't want to do all that math because I've come to learn that a lot of times the authors of the book that make these problems are not really interested in you doing a lot of math either. There's usually an easier way to do it. So I'm going to factor 20. So I'm going to say, well, that's negative 45 times 5 minus 4 times 5. Okay, well, let's just work on the numerator for a minute because the 5 in the 5 is in both of those factors. I can pull a 5 out to the front of these two factors, and then I'm left with a negative 45 and a negative 4, which is a negative 49. Okay, so then I'm going to do the same thing on the bottom. I'm going to notice, well, 45 times 9, I don't want to multiply that together, but 36 has also got a 9 in it. So I'm going to factor the 36 as 4 times 9. Okay, and then I'm going to write the plus 45 times 9. And since both of these have a 9 in it, I can pull the 9 out to the front, and I get 4 plus 45, which is 49. Now I'm getting somewhere because I have a negative 49 and a positive 49, which will cancel with a negative 1. And my answer is negative 5/9. That is my slope. And that was a lot of work, but we got there. Negative 5/9 is the slope. Okay, so that one was problem number 30. So now we're going to move on to problem number 40. And we're supposed to find the slope. But the slope is a little bit tricky. Okay, we're used to looking right there for the slope when it's solved for y, but notice that the x term is there. They've mixed it up. This is not in slope-intercept form. Let's put it into slope-intercept form. Negative 2x plus 4/5. Now, this is my slope because remember it's y is mx plus b. So this one right here is my slope, so my slope is negative 2. They were a little tricky with that one. Okay, so there's the slide up close. And on these, we're supposed to find the slope and the y-intercept. Anytime you have an equation in slope-intercept form, that's very easy, right? This number right here in front of the x is the slope. X is never part of the slope. I have a lot of students that will say the slope is negative 2x. No, the slope is just negative 2. Okay, so negative 2 is the slope. That's your slope. And then 3 is right where we should find the y-intercept. Okay, now down here we have problem 55 is in standard form. And that's the easiest way to find a x and y intercept, right? When it's in this form. Other than that, that's already solved for. But to find a y-intercept, don't I just let x be 0? So we let x equal 0. And when we let x be 0, I'm going to cover that one up with my finger real quickly. Okay? And then we're going to have 2y is 10. If 2y is 10, then y is 5. So y is 5 is the y-intercept. And the slope, what was the little trick I taught you? Okay, if it's in in standard form, you can turn it around to slope-intercept form, but you don't have to. Because remember, I did it for you on the board, and the slope, when it's in standard form, is always negative a over b, or, in this case, negative 3 over 2. And that is problem number 50 and 55. We have, okay, so we have that. Now we could write it in slope-intercept if we wanted to, or we could have just turned this around and solved it for y. But that should be what we get when we turn it around and solve it for y. And I will be back shortly. Okay, so let's hope to finish up 1.3 now. So we are on problem 60, and the instruction for problem 60 of 1.3 was to take this line and find the slope and the y-intercept. Well, this line is not quite in standard form. This is called the general form of the line when it ends in 0. So I'm going to go ahead and write it in its standard form because that is very easy. And we already know the trick of the standard form of the equation of the line. Our slope is always going to be negative a over b. And our y-intercept will always be c over b. Okay, so what we're going to do is we're going to use the little trick, and then we're going to go and turn the line around and make sure that we got it right. So negative a, remember the a is always with the x, the b is always with the y. So we got negative 5 over a negative 2 is 5/2. Okay, so that is going to be the slope. And then the y-intercept is negative 9, which is the c, the constant over here, divided by the b is negative 2. So negative 9 over negative 2, which is 9/2, is going to be the y-intercept. Okay, so I just did that by knowing the little pattern that I showed you, but now let's do the same thing by just turning it around and solving for the y. Okay, well, the y is negative, so what if I just put the y over here and then divide everything by 2? Then we'd have y by itself. So when I rewrite it, I'm going to have 5x, and I'm going to move the y over to the right, so it's going to become a positive 2y because it changes sign, and then plus 9. Okay, so then I'm going to divide by 2, divide by 2, and divide by 2. Okay, now this one's not quite in slope-intercept form because it's backwards. So as I simplify it, we'll move it around. So I'm going to put the y in the front now because the y was on the back side of the equation. But these 2's cancel out. So y equals 5/2 x plus 9/2. Okay? Now, we know that this right here with the x is the slope. And it was 5/2. And this slope we had found before was 5/2. And the y-intercept was 9/2. And this y-intercept we had found before was 9/2. All right, so the pattern works beautifully. Now this one says that I'm supposed to find the slope and the y-intercept and graph. Okay, now we can either turn this one into slope-intercept form, or we can use our A here and our B here. They're backwards, they're switched, right? We don't have our X in the front, but we could still use our negative A over B to find our slope. And if we did that, we'd get, this is our A, right? We get negative the A, so this would be a positive 2, okay, over the B, which is 5. So that would be the slope. And then the y-intercept would be C over B, which would be a negative 20 over 5, which would be negative 4. So that's what I did, just using the negative A over B for the slope and the C over B for the y-intercept. But we can turn it around, and we can get the y by itself. 5y equals, I'm going to send that 2x to the right, so it's going to become a positive 2x minus the 20. We divide by 5, divide by 5, divide by 5, and this goes out, and we get y equals 2/5 x. Well, there's that 2/5 again, minus 4, and there's that minus 4 again. So the pattern works pretty well. Okay, so that one was number 70. Now, the last thing I want to do in this lesson is I want to show you a word problem. Okay, and in this word problem, it says, Susie's Cookie Company had fixed cost of $1,250, so this is the fixed cost, and variable cost of $4.25 per dozen gourmet cookies that were baked and packaged for sale. Write an equation that can be used to determine the total cost when X dozen of cookies are baked and sold. Then determine the total cost of baking and selling 85 dozen gourmet cookies. Well, I'm going to cheat a little bit, and I'm going to just make it 20 dozen because I want it to be easy math. Okay, but we'll be doing it the same way. All right, so we're looking for an equation first. We're looking at an equation for the cost incurred by the company every time they bake cookies, and this is a fixed cost, so we're going to add that no matter what. Okay, so I'm going to add that. That's usually your overhead. He has employees that are baking cookies all the time. No matter how many he bakes, they're still getting paid a certain amount. Okay, so overhead and employees. So we got 1,250 is our fixed rate, and then this is per each dozen of cookies. Okay, so 4.25x. If x is a dozen of cookies, then wouldn't that be a good representative of the equation? Okay, can you see that little decimal? That's a 4.25 there. Okay, so now we're going to take our nice equation and we're going to plug in 20 for the dozen here. So we want to bake 20 dozen cookies and see what the cost is to us. So we're going to replace the 20, the x right there, with the 20, and when we multiply, that's going to end up being 20 times 4 is the 80, right? 20 times 4 is 80, but 20 times a fourth is going to be 5. So that's going to be $85 when I multiply that by 20. okay, and then added to 1250, and when I put all of that together, I get 5 and 13 and 3 and 1. So 1,000, and I don't have a decimal in there, so $1,335. Wow. Okay, but notice they have this much that's already fixed cost that they're gonna spend anyway, just by keeping open. So there's that problem right there. Okay, and that is the end of 1.3, and I hope that you have enjoyed this video and that it's helped you a little bit. And this is Mrs. A, and God bless your day.